Hello everyone. In this lecture of the Essential Calculus problem series, I will solve this problem. Integral of sine to the power of 7x times cosine to the power of 5x dx. In order to solve this problem, I will use substitution method. But in order to use substitution method, we need a function u, and the derivative of that function should be multiplied by dx to use the substitution method. Here we have a function of sin x. If we have sin prime, the derivative of sin x multiplied by dx, we can use substitution method. Derivative of sin x is cosine x. So in order to use the substitution method here, we need a cosine x multiplied by dx. We need this. But we have cosine to the power of 5x here. Now, this is a puzzle for us to solve. Okay, and let me solve the problem. Okay, we have sine to the power of 7x times cosine to the power of 5x, but I will split it into cosine to the power of 4x times cosine x dx, because in order to use substitution method, I need cosine x dx. We know that cosine to the power of 4x is cosine square of x square. Okay, now write the integral again. Sine to the power of 7x times cosine square of x square times cosine x dx. You know from the trigonometry that cosine square of x plus sine square of x is equal to 1. Then I can rewrite cosine square of x as 1 minus sine square of x. Now, rewrite cosine square of x as 1 minus sine square of x. Then the integral becomes sine to the power of 7x times 1 minus sine square of x square times cosine x. Actually, from now the integral is easy. Just we need to do something, and we will take the square of this. Okay, the integral is sine to the power of 7x times, we know that a minus b square is equal to a square minus 2 times a times b plus b square. Here we have 1 for a, and we have sine square of x for b. Then take the square of 1 minus 2 times 1 times sine square of x and plus square of sine square of x. This is equal to sine to the power of 4x times cosine x, that's dx here, dx. Now we will multiply sine to the power of 7x 1 by 1 into the parentheses. Okay, the integral becomes sine to the 7 of x minus 2 times sine to the 9x plus 4 plus 7 is 11. Sine to the power of 11x times cosine x dx. Okay, now we have a function of sine x, and derivative of sine x is cosine x, and cosine x is multiplied by dx. So we can now use substitution method. I will say that sine x is equal to u, then cosine x dx will be du. Now we will rewrite the integral again. We rewrite sine x as u, and we rewrite cosine x dx as du. Then the integral becomes u to the power of 7 minus 2 times u to the power of 9 plus u to the power of 11 times du. And I'll break down the integral into 3 different parts. U to the 7 u to the 7 du minus 2 times the integral of u to the 9 du plus u to the 11 of du. Okay. When we take the integral of x to the n, we know that we add 1 to the exponent and divide by the new exponent. And here in all these integrals we will use this rule. Okay, the integral of u to the 7, we will add 1 to the exponent and divide by the new exponent, minus 2 times u to the 9. We will add 1 to the exponent and divide by the new exponent. And for the u to the 11, we will add again 1 to the exponent and divide by the new exponent. The integral becomes 1 over 8 times u to the power of 8. But since u is equal to sine x, I will write here sine to the power of 8x minus 2 over 10 times u to the power of 10 sine to the power of 10x. Okay, 2 over 10 is 1 over 5, so I will write here 1 over 5 plus 1 over 12 u to the power of 12 and sine to the power of 12x. And since this integral is an indefinite integral, I will add the constant c here, and the answer is this. In the next video of this series, I will solve this integral, sin² of x times cosine to the 7x dx. See you in the next video.